Okay, welcome everyone to this session on how to build your own commercial CBRS LTE or 5G network. We actually, in this room, we actually have a full network, including the core network. And what Jordan Ratanowski, whom is the chief architect of Connect 5G, will take you through is actually how you build it. And you will see that the whole EPC and everything you need is on what you have in front of you on that desk. My name is Patrick Melander. I'm the chairman and CEO of Connect 5G. And I'll speak a bit about what we do in Connect 5G. But this whole session, it's a 3-hour session where we'll show you actually on how you can set this up. And after we've done here, you'll have your own 5G network up and running. We have all the different parts, and Eric, the Chief Technology Officer from our partner Xtreme, he'll take you through what the different parts are in tandem with Jordan. Okay? Sounds good? All right, so let's start then. So I'd like to say thank you to the Linux Foundation for giving us the opportunity to speak here today. I'd like to say thank you to Arm, the team in the back there that has made it possible. They have sponsored many of the devices, but also been an instrumental partner in the journey we've had to achieve this step. So thank you to Arm. Thank you so much. So who is Connect 5G? So Connect 5G, we are a telecom services company. We formed about 3 years ago on the foundation that your telecom network, we start with the customer experience in mind. The only way to get great customer experience is to have fantastic quality. And the only way to get there is to have smart tools, automate as much as you can. And the second thing is a great team. And I would say that the team you have here today is an example of that. So a bit structurally, we are 120 engineers and team members of Connect 5G. We are headquartered in Dallas. We have about 20 team members in Dallas, about 100 team members in Brazil, and most of them have 5 to 25 years of experience in telecom services. We do integration, so we help roll out the networks you see here of 5G with T-Mobile, US Cellular, AT&T, and then we have 46 fixed wireless customers that we help in the United States. And we only work with the United States. So how do we do that? Well, you'll see part of it, but we really try to automate as much as possible. So we do services as a software. We try to drive the automation and the human intervention as little as possible. So that's briefly about Connect 5G. So the areas that we work with is build services. So we help our clients build their networks. We do integration services, we do optimization of those networks, and we do also operation and maintenance, if you will. We cut across all the platforms, 5G, 4G, 3G, CDMA, CBRS, small cells, C-RAN, and IP, and we work with different vendors. So today, we are going to demonstrate a project we've had going for 2.5 years, which is the Magma EPC. So when we were working with our fixed wireless customers, we saw that there was a big need for them to drive cost efficiency. And cost efficiency you get by combining 2 things, really. Number one is to have the best possible radio. And in the title of this seminar, you can see Tier 1 radio. And in our world, Tier 1 is an Ericsson base station. It can also be Nokia or Samsung, but Ericsson is the main one that we're working with. The other part that you need in the equation, and why you need a Tier 1 radio, something that covers a lot, is that every site costs a lot to build, right? But on the other hand, if you can have your core network deployed inside the base station, and in essence, what you'll see is the core network is actually, when you have the core network this size, you can actually put it inside those base stations. So now you have a network in a box. and it can operate completely autonomously. And you'll see, Jordan will speak more about it, but the structure of Magma allows you to deploy it on the edge inside the node or in the local village or city that you are in, so you can break out internet locally and save a bundle on transport. Or you can put it centrally in a data center. So you have that flexibility with the Magma. And why did we choose to go with ARM? Well, the original Magma code, as many of you know, it was based on x86. But with that platform, we could not use it for massive MIMO. Why? Because the throughput with massive MIMO, 4x4, 64x64, would not yield the throughput we needed, particularly now that we also have implemented it on 5G. So we took the decision to port the Magma EPC from x86 over to ARM. And the result is obviously a device that is much more, it's smaller, it's much higher performance, and it consumes much less energy. And you can deploy this, as I said, on the edge, in the mid, but also in a Graviton instance, for example, in a data center. So you have that flexibility. So that's why we took that step, and we have now, last year on the ARM Dev Summit, we actually integrated a whole EPC on a Raspberry Pi and put it inside a 64x64, and we have actually not only done it in a lab environment, but we have, together with Xtreme, we have ran it commercially. 4 weeks ago, roughly, we finalized the porting and the launch of 5G and 5G SA. So we're right now up and running with 5G SA, not only here in the lab, actually what you're seeing here is a 5G SA, but we're also live in a network here in the US with this setup. So today we're going to show you how that is done. And with that, I'd like to invite Eric to speak about Xtreme and also the power of Ericsson.
Perfect. Thank you, Patrick. So as Patrick said, I'm Eric Whalen. I'm with Xtreme LTE. I'm the CTO there. And just a little bit real quick about us. We started as a cellular provider in north central Pennsylvania, south central New York. We also have a WISP network, so we're an internet provider as well. And one of the things that we discovered along the way is the need for a solid network for rural areas, right? There's a lot of things out there there's a lot of tools in the toolbox and different things that'll do the job, Wi-Fi setups, a lot of different ideas, right? But as we start coming into a lot of this funding and being able to get government funding, you have to have a solid network that can handle the capacities, deliver the speeds, and all of that. So that's when we decided to really get into a partnership, and we chose to partner with Ericsson at the time. We're very familiar with them. They've been in our network for probably 25 to 30 years now. What that gives us the ability to do is we're able to then come in and take the carrier grade equipment, the tier 1 equipment, we can tailor it to the fixed wireless world so that the cost now comes down and it becomes affordable to rural markets. These rural markets can now deliver the same quality network that the large players are doing and in larger areas. So with that, what we have done is we've become the end-to-end provider for a carrier grade network. Everything from the core network to the RAN to the customer equipment at the house, management, the whole works, right? So one of the fun parts of this partnership with 5G, first of all, they handle a lot of our integrations now as we've grown. As Patrick said, we've got 45 networks in the country that we've rolled out. In those networks, we actually have a couple in Canada, one down in Puerto Rico with a second one coming on in Puerto Rico. And as we've grown, we've had to increase capacity for support, for integration, all of that. And that's where we partnered with Patrick's team to do that. And it's helped us to become more successful. So part of this then, like I said, is we're trying to deliver this to the rural market. There's a few things that happen as we start talking about EPC. So we already have a core that we use. One of the big hurdles that the rural carriers have is the ability to justify the cost of a true LTE network or a carrier grade network, not only that, but maintain it. So one of the things we've done is we've centralized the core in our network, and then we offer core services. We put the gateway MME in the LTE world out to the customer. They come back, connect us for signaling and all of that, and it helps cut the cost on their network, gives them the capacity to be able to build. So with that, what became a great fit is this Magma project that we're working on with these guys. What this does is, again, it lowers the cost. It eases the manageability of it. And the other thing that we've run into is with some of the smaller networks, somebody that's got, 3, 4, 5 sites that we've serviced. With that, they don't always have the ability to house the devices at the edge to be able to deliver better performance, lower latency. They're having to haul everything back to a centralized location. Part of that problem is your tower sites, real estate is precious, right? So you've got to have a way to fit this equipment. And what you cannot do is take a 4 to 8 Dell server rack system and throw it out on a tower site easily. That's where this comes in. So this is really an attractive thing for us to work with. Our customers are thrilled about it, and it's also helping us to move, as Patrick said, into 5G quicker, 5G SA, right? So again, I'm not going to waste a lot of time on who I am or who we are, but our mission at Xtreme is to be able to help with everybody else getting broadband internet out to the rural masses where they're underserved, unserved, all of that. And wirelessly, we can do that much faster, much more cost effectively than a lot of other cable fiber providers. And then again, with this type of partnership, we can help to reduce that cost, reduce the maintenance, and the staffing necessary for these smaller WISP to be able to support it. So that's a little bit about us. I'm going to pass it off to Jordan. He's really the meats and potatoes of the show here. He's the guy you want to see. So.
I agree, but you'll have to bear with me one more minute. So what you can see here is actually a massive MIMO base station. So this is the base station cabinet. And what you can see here, so that's one of Indigo's networks or Xtreme5G's networks. And inside that, it's a bit poor sharp, but here you can see the device. That's actually the EPC. So this is now a G-Node B, a network that is out there at the tower. So if everything is cut off, we can also provision the local subscribers there. So if you have a mining operation, if you have a factory, or if you have any other type of campus where you every now and then have difficulty with the internet backhaul, as Eric mentioned, now this operates autonomously, right? So Jordan will go into this in more detail. The other question I got actually before we got started is, what is CBRS? CBRS is a spectrum in the mid-band, so around 3.65 gigahertz, which is unlicensed. So you have license called PAL, but you also have GAA, so general availability, meaning you literally can build your own network. If you're going to set up low power ones, this is a high power one, obviously. We have put it on low power so we don't need to get a grant. But if you operate with low power, you don't even need to get a grant. You can actually, if you have a lab, for example, you could do that. If you want to operate outdoors, you need to have someone certified to set it up. But you can still set it up very easily and in a way that really transforms. The other thing is, this base station, a few hours before we started, was an LTE base station, an Ericsson LTE eNode B. We converted it with software, which is one of the advantages, obviously. Just with software, we could convert it, and we made it 5G. Okay? So that's the whole story that we have, and we actually demonstrated even that transformation at the Arm Dev Summit last week, if you want to tune in and see how we did that. In less than an hour, Jordan demonstrated how this was done. With that, our chief architect, Jordan, welcome to the stage.
Thank you. I don't know if this works or not.
It's muted right now.
Let's see. Yeah. Let's see. I think it's okay.
Now it's working.
Patrick, I think this is yours. Yeah. Yeah. Okay. So, welcome. As Patrick mentioned, we are going to, I will show you how to integrate and how to install Magma on this small device and how to integrate it into a radio. Some of you can follow me. So whoever is next to the device or whoever wants, we have a couple of devices free. All you need to do is to SSH to the device. And if you don't know how to SSH to the device, then, follow up and see what we can do here. But before we start, working on the installation itself, I will tell you a little bit about Magma. And then during the installation, there are the boring parts where we are going to wait for something to be downloaded from the network. It can take even up to 10 to 15 minutes. Depends on how many people we will download at the same time and how is the internet speed and so on. At that point, I have prepared some slides, and then we can discuss about certain things. What are the Magma deployment options? We can discuss about CBRS itself. And then, if we have more time, we will go with questions, and we can go with open discussions while we are waiting for the things to be downloaded. Okay, feel free to interrupt with questions because this is a workshop. We should have enough time. Last time we did it in almost an hour. Now we have 2 hours in front of us, so hopefully we are not going to have big problems, and then we will finish everything which we planned. In worst case, we already have pre-integrated things here, so we can show it directly on the pre-integrated things. So let's start with what's Magma. Magma is open source evolved packet core. It was built from ground up to be cloud native. So the whole idea for Magma was to have a device which sits at the edge, which you can move it in a different deployments, which we will see later. But natively, it's created to sit on the edge. And then this device, or you have multiple devices now in your network, are going to be controlled by the orchestrator, which is actually a cloud part. So this is a part which sits subsystem which sits in the cloud, and it is making sure that all these devices on the edge are properly provisioned and they are working. They are properly operational. In certain type of deployments, we have the third part of the Magma, which is the federation gateway. So we can deploy Magma as a standalone network itself, or we can deploy it as a part of other legacy network with existing, where we have operator which has existing legacy nodes. In that case, we will use the federation gateway in order to integrate to these existing nodes which are talking the 3GPP protocols. Or in case of roaming, because we will have roaming with the partners who are operating on talking the 3GPP protocols, then we will use the federation gateway in order to integrate with them. Now, the AGW itself, today we will show installation of the orchestrator and the AGW, but the most interesting part would be the AGW. So the AGW itself is the self-contained network. So everything that you need for a 3GPP compliant network, you have it in that box. The external interfaces are compliant to the 3GPP. However, the internal interfaces are proprietary. They are done with the gRPC. If somebody is familiar with the architecture of a LTE network, so we have in the device, we have the MME, SGW, and PGW. MME is the control plane, is what is controlling the access to the network, while SGW and the PGW are data plane, and it's controlling the data connectivity of the users. And then, as I said, all these components, inside, on the next slide, I will show you even more components, but these are the key components. And all these components are talking to the orchestrator with the gRPC. Now, going to the slide now, a little bit more boxes. We have the MME, who is actually in the case of 5G, it's the AMF. Is the same instance, which is converted just by one software switch. So I will show you how we put one software switch in the orchestrator. We restart the AGW, and it becomes 5G. And then the MME is connected to the pipeline D, which is the SGW and the PGW. And pipeline D is based on the Open switch, which means it's a software-defined network. Having said this, I mean, you don't need to use it only for the 5G or for the LTE. You can have cases where you use this software-defined network with all other type of applications which you want. So you can build your own services on this software-defined network and do your own routing, your own policies for a special application. Then we have the session control, and we have the database, the subscriber database. So the subscriber database, where if in case we are provisioning the subscribers locally, all the subscribers, the subscriber information, the KEYs and the OPCs are going to be stored, which means if we are going to lose the connectivity to the orchestrator, they can still connect. Okay, now, as we said, in this workshop, I will show you how to build the orchestrator. And you can build and deploy the orchestrator either with Kubernetes or with Docker Compose. Docker Compose is used more for test lab environments, testing, or quick proof of concept. While if you go into real production, you need to go with Kubernetes, and then here we can help you. We can help you install your own Kubernetes cluster and help you deploy the orchestrator on the cluster. Then we are going to prepare the device for the installation. Some of the preparational steps I already did last night. Hopefully they work. We will see very soon. And then we are going to here, I mean, we made the mistake, so we are going to install the HGW, but not on the Nextcom DT. We will install it on the solid run device. And then we are going to integrate the HGW with the orchestrator. We are going to provision one subscriber. And then we have a simulator for 4G, which is here. Then we will use this simulator to connect to the HGW and connect to and pass a traffic. For the people who will follow with me, when you are ready with your IP address, we will set it up, and then we will test if your installation works or not. And we will see if we can troubleshoot certain things and make it work if they don't work. Then I'm going to show you how to switch it to 5G. And then, because we want to show you how 5G really works, we have already a device which is already working on 5G operating. We will connect to this device. We have the CPE on the other side, and we can even connect through Wi-Fi to the CPE. So some of you can connect with your phones, test, see how it goes, see how it feels to be connected to a homegrown 5G. OK, so let's move. Yeah, so as I said, we will deploy the orchestrator on the DigitalOcean droplet. We will we will install the HGW on the solid run device, and then we will use the SRS, the simulator on the Rift Raven. This is x86 box. And then for the 5G, I mean, we have the orchestrator deployed on the DigitalOcean droplet, already running. And then we are already running it on a ClearFog device. In the lab, we also have these other devices which we can use, but we are not bringing them here. And then we have the Ericsson BBU and Ericsson RRU, and this nice antenna which is pointed into me. And it works. OK, so let's start with the installation of the cloud. These are the minimum requirements for the cloud installation. As I said, it's native, it's cloud native, so everything is packaged in Docker containers. We will install it with the Docker. We will build the containers. And minimum requirements, it's 2 CPUs and 4 GB of RAM. However, these are bare minimum requirements to install. If you really want something which is operational, you will need to allow more CPUs. And now, during my installation, I will put on the highest tier node in order not to wait too much for the compilation. If we put it on a low amount of CPUs, we will wait longer. And then you need to have Linux OS, Linux operating system. We use Ubuntu 20.04. For the orchestrator, it's not mandatory to use Ubuntu 20.04. However, later when we come to the AGW, it will be mandatory to use certain version of Linux and certain version of the kernel itself. So I will show you the installation of the tools. I will show you how to install Docker, and we will go with that fast. Then I will show you how to fetch the latest repository, and then building the orchestrator, building the NMS part, because the orchestrator contains two major parts, the orchestrator itself, and the NMS, which is the front end, the UI. And then we are going to show how to initialize the database, how to configure the basic settings of the database, and then we will create one user. Once we finish this, we will move to the AGW itself. For the people who are following, you can install your own orchestrator with me if you want, or then when I install the orchestrator, we can use the same orchestrator to provision your device. I mean, it's up to you. Okay, so now let me go to the, and let's see if this works. Good. Okay, so now, first I'm going to go and create a node. So I will create a droplet. You don't need to, you don't need to use DigitalOcean. You can use any other cloud provider. You can even install it in your premise if you want. But we will use let's use San Francisco site here. We will put Ubuntu 20.04. We will go with the regular, and then we will go with the highest one. I will use my keys, and then I'm going to name this device here Magma Orchestrator 02. And when everything is ready, I'm going to create the droplet. Now we will allow a little bit time for the droplet itself to be created. And this is not the boring part. The boring part comes later. This should finish in less than a minute. Yeah. Okay, now I have my IP address. I'll activate my key. Okay, and now we will SSH. And we are on the node. So first thing to do is to make sure that we are not going to have Docker. For sure, we are not going to have Docker, but because we just created the node, but we need to assure ourselves. And then we are going to install the tools required for the Docker installation. Okay, some of them are already installed. Then I will prepare the directory or the folder where we will keep the keys of the repository, because we will install the latest version of the Docker. Then I'm going to define the repository of Docker in my installation, and I will update the repository. So now I can install the latest version of Docker. And you can find this information on the Docker page itself, so you can follow for your operating system how to install the latest version of Docker. Now I'm going to do the installation. And the benefit of running these things in a public cloud is that many of the things are pre-cached, so it will be much faster. And you will see later when we come to the things which are quite specific to Magma itself, which will not be pre-cached, then it will be a little bit slower to run. And the other thing to know is that the latest version of Docker has the Docker Compose as a plugin. However, Magma is expecting the old traditional Docker Compose. But the fix for this is quite easy. We just need to link the plugin to where it used to be Docker Compose and to verify that we have the Docker Compose with us. And now it works without. So you can use it with the plugin and you can use it traditionally. And we are going to verify that Docker is up and running before we continue. OK, so once I'm ready, I'm going to fetch the latest. I'm going to connect this node to the repository of Magma. And Magma is it's on GitHub. So it's public. You can go and download it. You can go and install it. And since it's an open source project under the Linux Foundation, everybody is free to join us and help us make it even better. So let's connect to it. And today it's quite fast. Last night I was testing this. It was quite slow. So today, during the day, it's really fast. So it's good. OK. And then once I have the repository with me cloned, I will go to the repository and I will check the stable version, which is 1.8. OK, so once we are on that branch, I'm going to go ahead and start building the orchestrator part. I will go into the orchestrator folder, and then I will go with the build all. And now this can take up to 10 to 15 minutes. So while doing this, let's go back to our slides. And we talk about the CBRS. So Patrick started a little bit talking about the CBRS. CBRS, as we said, is the open spectrum. And I will keep the slides like this just for us to follow up what's happening in the background, by the way, just to make sure that we are following the things. So CBRS stands for the Citizens Broadband Radio Service. It was created by joining two existing bands. And it spans the frequencies from 3,550 megahertz to the frequency of 3,700 megahertz, which means that we have 150 megahertz bandwidth available in this band. Also, it's known as a band 48. So this is how people are referring to this band 48 or CBRS. It is lightly licensed, so it's not fully unlicensed, like it would be 2.4 for the Wi-Fi. It's slightly licensed, which means that there are certain rules who and how it can use these frequencies. And in case if you're using them for LTE or for 5G, then this band in LTE and 5G frequency planning is defined as a TDD, which means that you have only one carrying frequency for uplink and downlink. And then on this frequency, the time is divided in frames. So certain frames are belonging to the uplink. Certain frames belong to downlink. Now, devices, when the time comes for the uplink, the devices will start sending the data to the G node B. And when this time slots finishes, then the G node B will start sending the data to the device. So they not be in case of LTE. And there is a gap period because of some of the devices could be in a movement, or some of the signals could be reflected. So there will be a gap period in between the frames, which actually it's waste of your bandwidth, basically. So you will lose that part of the time slots. Now, as I said, it's slightly licensed. And it's slightly licensed. The licensing is divided into the 3 tiers. Into the first tier is the incumbent access. And these are the existing users of these 2 previous bands, which are mainly the government itself. So these are government agency, and they have a plan to abandon these frequencies and to move their equipment to different bands. However, if you are in an area where they operate, you cannot use the spectrum. It will belong only to them, or that part of the spectrum will be reserved for them. The next tier is the priority access. Now, if you don't have these incumbents in that area, you can go and you can buy yourself the priority for certain frequencies, so for certain channels. And the size of the channels in the CBRS are 10 megabits. So you can buy a certain amount of channels, and they will be dedicated for you, which means that none of the free users can come and use your channels. And then there are the free users who can use them without, they don't need to pay anything, so the use is free. However, depending on the way it is used and depending on the power in which you will radiate, you will need to connect yourself to the SIS, which is a way to manage the frequencies and the power. And the SAS is going to control your device. And if somebody from the other tiers come into this area, it will lower or it will change your frequency or it will lower your power. So why CBRS is interesting? I mean, primarily it's free, you can use it. So you can create your own lab, you can create your own private network using it. It's reliable, so it's not, I mean, it's not like, although you can share it with other users, it's still reliable because it's controlled by the SAS. It can be used for the college campuses and higher education. It can be used in the hotels, into the hospitals, into the mines, industrial Internet of Things, warehouses, sports stadiums, hotels, and of course, it can be used in the rural areas for the wireless internet service providers who can use it to immediately deploy services. Now, I mean, Eric, you can help us to why it's so important to have the free CBR, I mean, the free spectrum. And what is the price for actually for buying a spectrum?
Right.
This would be.
So as Jordan touched on, there's a couple of tiers, right? The incumbents, they have free reign, they can use whatever they want. Everybody else gets bumped for them to be able to be served. The PAL users, as Jordan touched on, there was an auction here, well, I guess it's been a couple of years now, where you had your chance to go in and bid on spectrum. Any one entity can own no more than 4 channels. I'm not smart before. Oh, yeah. Anyway, so this will be on here in a minute, and it'll sound like I'm yelling at you. And then the GAA, as he said, is the spectrum that's available to anyone. The GAA plays more like the traditional unlicensed, the 5 gig, the 2.4. Pretty much anybody can come in, do their thing. It is still has to be registered to the SAS. But the difference between the PALs that we talked about and the GAA, the PALs are protected, right? So if I've got a PAL license and I'm operating an area, somebody who's GAA cannot come in and step on my frequency. If I'm a GAA operator and another GAA operator comes into the area, now you got to play friendly with each other for your network to work, right? So you both can potentially operate on the same channels. There's some power things you can do, a lot of things you can do to make it work. But again, the importance of the GAA is the people that couldn't get it, the people that chose not to unwisely, I would say in many cases, because the priority access license certainly gives you better control over your environment. Now, what's interesting is that spectrum, if I'm a PAL owner and I've got 4 channels, I don't deploy it. Anybody can come in and use it as GAA until such time that I decide to employ it. To deploy it. So what that does is it kind of helps with some of the spectrum warehousing that used to happen where people just bought it up and didn't use it. Now it's not available. If it's not being used, it's available. The SAS knows it's not being used. It'll let you get your grant. Okay.
I mean, we are operating now here. We are not registered, by the way, here on SAS because we are operating on a very, very low power.
Correct, yeah. So as we discussed, you have to register any Category B device has to register with the SAS. Category A is a lower power, indoor, there's different criteria, right? We're operating this as a lower power as a Category A, so we're not registered with the SAS here today. But in a true environment and what we're doing in our network, these devices are registered with the SAS. They're getting the grants. The SAS is telling us what frequencies we can use, what power we can transmit at, and it has the ability to suspend us in the event that an incumbent, such as a government, the military, whatever, if they have an operation that they need to do to use that spectrum, it'll push us out as a priority access. It'll push us out. We'll get another grant, and the GAA people then would get pushed even farther out, right?
Yeah. Okay, so now we are ready with the installation. So it was properly planned, the time for this discussion. So once I have built the orchestrator, now it's time to build the NMS. Once again, I'm using I will go to the folder where the scripts for NMS are, and then I'm going to execute the build. And now we will have something like also 4 to 5 minutes while this build is going. So, and in this time, I mean, the plan was to speak about the devices which we are using in the lab. So let's see, yep, this was the plan. So as we said, I mean, we are using the solid run device here to, yeah. No, I mean, I want to see it how it goes, yeah, because we don't have slides for this. So this is the solid run device which we are using today to install, and this is the device which is running the 5G and the LTE as well. This is Marvel chip, and the reason why we went for these devices is for this interface here, for the 10 Gbps SFP interface. The reason we need this interface is because when you come to 5G, when you come to serve more than one sector, your theoretical throughput immediately goes after 1 Gbps, which means that the ports on the normal devices, it will not be enough to serve your high capacity traffic. Now, if you go with the 6 sectors, then it will be almost impossible to serve it with the device which doesn't have these ports. And this was the reason why we were porting Magma to Arm, because Arm gives you SoCs which have which are I mean, in the low price range and which already have these interfaces. If you need to deploy this type of device with different architecture, then either you will end up with a rack mountable server, where you put your own, you put your 10 Gbps card, or you end up with something which is heavily expensive and it's suited for a field deployment. On the other side, the other benefit which we got, I would say for free from this porting, is the power consumption. The power consumption of these devices compared to the power consumption on the other device, which is in front of me here, are quite different. Although this device is x86 and it has less capacity, it requires even bigger cooling because it consumes lots of power and has lots of dissipation. So, yeah, I mean, as I said, these are the reason why we went with the ARM as a SoC, and we are working with the device manufacturers now to get devices where we have more than one interface, because with this 10 Gbps interface, basically we can use 5 for uplink, 5 for downlink. So the way that this is installed here, we have 2 virtual interfaces configured through a VLAN. So we have the RAN VLAN and we have the core network VLAN, and then we need to balance between the uplink and downlink. If we have, I mean, in future when we have devices which have more than one SFP, then it will be we can use this device to deploy on a places where we need higher capacity. Good. Now we are finished with building the packages. So the boring part finished. Now we can go and start the things. So I'll go back to the orchestrator. And the reason I did it like this is just for time. I mean, I was trying to save the time, because usually when I do it at home, I build the orchestrator, I start the orchestrator, I build the NMS, I start the NMS. But I did it in this way in order to be faster, because even now when I'm running, though we have built some of the containers, we still depend on community containers. So we need to fetch now these containers before we can start everything. So, yeah, but this should be fast. Actually depends on the. Sometimes it's fast, sometimes it's slow, but I don't expect this to go more than a couple of minutes to download. So Eric, we need to fill this couple of minutes now. Yeah.
When you put the core close to the RAM,
Hmm?
how do you support basic mobility in this case?
No, so yeah, good question. Mobility, when you put the core next to the RAN, mobility suffers definitely. But still, you can have local mobility scenarios. So you can use X2 for the local mobility, or you can have because as I said in the beginning, it's a software-defined network. So you can configure the way that you have something in front which helps you with the mobility. But yes, I mean, the use case for Magma at the moment, or the priority for Magma project at the moment is not the mobility itself. It's more the fixed wireless networks or the private networks where the mobility doesn't come into big play over there. And even in private networks, if you have, let's say, warehouse where you have these moving machines which they need to hand over from one side to one side, then you can deploy, we will see on the later slides, you can deploy it in a way that mobility will still work for you. Right? So, yep, we have started the orchestrator. Now let's go and start the NMS. Mm-hmm. Sorry? Mm-hmm. Not within the orchestrator, within the data plane, within the HW, yeah. So it's just open with switch, and RUI is the controller. So the controllers are built on RUI, the Python, basically. Okay, so we have them started. I will just check on them if they're up and running. Okay. So it's still starting. We will wait a little bit for it to fully start. And then after we start, then we are going to provision the test site, the test network, and then we will create, or the test site actually, and then we will create our network in this test site. Okay, still starting. Oh, now it's healthy. So already started. So now since everything is started, I go and I run the script which will provision the default settings. And if you follow closely what this script will write on the terminal, you will see the username and password which will be provisioned for your access. And you will see the name of the site itself. So, and here it goes. So we have here the username and password, and we have the username and password for the site itself. So now, because I was installing this without DNS, I will go ahead and I will fake the DNS inside of my hosts file. But if you're installing this in normal conditions, you are going to install it with the DNS. And I already have prepared from another setup. And I will go ahead, grab the IP address, insert the IP address here, and we are good to go. So once I have done this, let me go ahead and open another persona here and use the Magma test. So by default, Magma, so this will be your DNS, magma.test. And the default site which is created, it's called magma-test site. So when I go over there, because we have used the snake oil certificates, I need to say yes. These are my certificates. I agree to proceed. And once we are there, we have the login page. So the username, as you have seen here, it's admin@magma.test. So I can grab the username. And the password is password 1234. strongly recommend it to change, even if you are doing it for your own demo, unless you are in your private home, so then you don't need to worry. So once we are there, for the first time, because this is the first time we are accessing this site, we will be asked to create network. Up to now, we have not created network. So I will go ahead and I will add a network, and I will name the network very cryptically, which is 001010. And this is the MCC-MNC. And this is how I personally like to name the things inside Magma. However, you are free to create your own terminology and your own nomenclature here. And I will name the network as test network. Description. Sorry, I will do the description test network, and the name will be the same. And then on the network type, if you remember in the beginning, I was saying that you can deploy it with the you can deploy it as a pure LTE, or you can deploy it in the federation, or in a combination with federation and LTE. I will deploy it with the full LTE at the moment. And I will go ahead and save. And now we have our network. So once we have our network, I go ahead and I start going to the network itself to make sure that this MNC and MCC are correct. So I'm using the MCC 001 and the MNC 01. If you're creating your own network, you will need to use proper MCC, MNC, which are actually regulated by the government. So later, when we have more time, I will ask Eric to explain to us how we get these numbers. But 001 is known to be the network which is used by for the experimentation and for the universities. So doing it at home, feel free to use this network. And then I need to create, in the network, I need to create APN. So the way that for LTE and in 5G, we get data for the subscriber, to put it in a very layman terms, is that the device of the subscriber will connect to the certain APN. And this APN gives you the priorities, and this APN gives you what the user or where the user can go with his traffic, where the user can send the traffic. So I will add the standard APN called Internet. Okay, and then the class ID will be 9, which is the standard class for the normal data traffic. And then I will put the priority level of 15. Now, by default, it will be 1 megabit per second, which is slow, so I will go ahead and make it 1 gigabit per second, if they can. And then I'm going to go ahead and save. So now we have our APN, we have our network, we have our APN. All we need now to connect to the site which we will create is subscriber. So I will go ahead and provision one subscriber. Let me just find yep, these are the subscriber itself. So I will go ahead and create a subscriber. So I will go add subscriber, add new role. I will put the IMSI of the subscriber. And the IMSI is required to start with prefix IMSI. This is the convention in Magma. So I'm putting it, the IMSI, MCC, the MNC, and then my subscriber is 000001, or the first subscriber. Name, I will just put the same, IMSI, and then we have the KEY and OPC. The way that the authentication is done into LTE and into 5G networks is through these two keys, which are stored in the SIM card. And they are used for the challenge, for the crypto challenge. So when the device is attaching to the network, the device will share its IMSI. And based on this IMSI, the network will generate a challenge key. And the device needs to decipher this challenge key, generate the challenge response. And if both are matching, then the device will be allowed to access the network. So basically, the device is authenticating the challenger, that this is the correct challenger. And then if this is the correct challenger, the device will generate the SIM card itself will generate the response. And then this response is sent to the challenger in order to authenticate the device. So I will use this standard. And these keys are generated with the strict algorithm. So this is why I'm using, I'm not typing any key because it will not work. I'm using something that is already known to work and generate it. So after I have put the authentication key and the OPC, I need to define which data plan. In this case, it will be the default. And then I need to define, well, what is the default APN for this subscriber. If the device is not going to send the APN, so the device has option during the connection to send the APN or to request certain APN or not to request certain APN. And then you have option to allow this device to connect if there is no certain APN, which means that by default it will be internet, or I can prevent the device without APN to connect to the network. And the device can be connected to more than one APN at the time. So by example, you can have APN to send your data and APN to send the voice, or APN for telemetry and APN for the control, administrative control of the device. It's up to the planning on you when you plan your network, how you create these APNs and how you create the routing behind the APNs. So I will go ahead, save it. And now we have our subscriber saved into the database. So we are almost ready with the orchestrator. The only thing which I need to make sure now is that the orchestrator generated the keys. And these keys are going to be important later when we provision the AGW. So I need to verify that I have all the keys here required. And on the AGW, I will need the content of this key here. So I will prepare it, and then when we come to the AGW, we are going to use it to pair the AGW and the orchestrator, or for the AGW to call home to the orchestrator. OK, so now, having said this, we are ready to install the edge device. So before starting the installation of the edge device, any questions about the orchestrator up to now? OK, then we are going to start, and I will explain about the edge device itself. So you can have one or more than one edge devices deployed in your network. And it's not required that, I mean, you can use different type of deployments, which we can see later. So it's not required that if you have one site per device, for all your network to have one site per device. So you can mix and match based on your planning for the data traffic and your planning for the amount of subscribers you're supporting. Minimum requirement for the AGW devices would be 4 cores and memory of 4 GB. However, this is the bare minimum as previously. So I strongly recommend to have something which is 4 cores is still OK, but at least 8 GB in the RAM itself, in the memory itself. And then if you are planning to go with 5G, you will need to have at least one 10 Gbps interface, or 2 10 Gbps interfaces are preferred. But I mean, as Patrick mentioned before, we have installed, last year we have installed AGW on Raspberry Pi. So you can use devices like Raspberry Pi. They don't need to be very expensive to install and test your network. However, I don't recommend running real network on Raspberry Pi. OK, so in this demo, once again, I will show you how we install some of the tools. I have cheated a little bit, so I have pre-installed some of the tools on the cards, just because I was scared that we might not have time to do it. Certain things can take even up to 30 minutes, so I didn't want to waste time. So then I will install some of the additional tools, and we will verify that we have the proper kernel installed. Then I'm going the user is already created, but I will show you how to create additional user, which will be used to access the device. Then we are going to download this certificate, which we have seen before. In our case, we will use VI to copy-paste the certificate on the device. And then we are going to create the configuration for phone home, how the device will go and connect to the orchestrator. And then we will start the installation. Once we start the installation, it will take something between 10 to 15 minutes. And if we are not lucky, it will go even 20 minutes. So at that time, I'm going to talk a little bit more about the different ways you can deploy Magma in your network. and then we will see, we go with Eric a little bit more on the discussions. Okay, since we are ready with this, let me go ahead and start. Now, for the people who will follow this with me, there was a number on top of your device, and based on this number, you will have the IP address for the device. So the IP address to access the device, and let me create it here now for a short on a slide. So the IP address will be 10.250.240.x, where x is the number of your device. It's actually 1x. So if you have card which says, so I think you have 15. Yeah, so here it will be 115, and the next will be 116. So if everything is okay, you should be able to connect to the device. If not, we will see what's wrong with the device itself. And then we have, if you have noticed over there, we have two cables coming out of the device. So one is the core, the other is the RAN. I will show you later how we find the address of the RAN itself. Okay, so housekeeping in order, let's go and start. I have already connected the device here with on the console itself, because I will show how to prepare the device, but your devices are already prepared. So if you don't have cable to connect to the console, you don't need to. If you want to connect to the console itself, here is the, let's see the speeds. Yep, so you need to use 115/200 as a speed, and it's 8 bits, no parity, and 1 stop bit. So 8 and 1. And when you connect, you will have, I mean, if you are operating on Linux or on OS X, you will have this type of name on your device, and you can go ahead and connect to it. So I'm already on the device. Let me power it up. Okay. Huh? No, this device will be AGW. It will be the core itself. The CP is over there, and then yeah, Eric will speak about little bit about this device here. So that one is the core. Yep. So the device is already booted. The standard user is Magma. Password is Magma. So I will use Magma. And then I can go, and since Magma is part of the sudoers, I can go and I can just become super user. Now, if you're on the terminal, you can use root. I mean, it's not too much secure, but since we are now in a demo mode, we can use this type of passwords. So once I am on the device, and you manage to connect to the device? Yeah, so.
Oh, I'm sorry. Do you have access?
Huh?
So you don't have the same network. Am I supposed to take one of these so I can escalate you to it?
Yeah.
I need another cable. Or do I just take it?
No, you to go on the network. Yeah. I mean, we can get cable from here if we don't use. Yep. No, if you get the cable out, you don't have the IP address anymore. Yep. But what I can do is this: you can get this cable here, and I will find the cable here on the switch itself. And then I will connect you.
George, you want to do the same?
Yeah, I want to move it to the odd numbers. Yeah. This should be the one. So do you have network now? Yep, good. OK, so, and as I promised in our discussion, my first command is always set TTY, because I'm on the console itself. So I go ahead and set my TTY, and then first thing I need to do is I need to update the device, but it's already updated. Hopefully nothing changed since last night. And then I need to upgrade. Also, I don't think that something is upgradable, because last night I've created the image and everything is up to date. And afterwards, I need to install the packages. So to build the AGW, because during the installation, certain things will be built. AGW, as I said, depends on this Open vSwitch. But the Magma have created a vPort for Open vSwitch, which is kernel module, which needs to be built. This means that you need to have the kernel. If you're using your own kernel, you need to have the images, the headers, and the libraries for the kernel for the device I mean, during the build for the device to be able to build the kernel module. Now, it's the supported to the recommended kernel will be 5.4. However, on these devices, we are using 5.8. So up to kernel 5.8, it's, I mean, you can use it. After kernel 5.8, you would need yourself to start building and porting the modules which are coming with Magma. So you need to do custom installation with Open vSwitch. Or, as I said, we in Connect5G, you can come to us. We can help you and install it for you. OK, so once this is done, I will just verify that I have the proper kernel, which is the case here. And then once I have this, I'll go ahead and this I need to skip. So basically, I created the device in your case, the network adapters. So because in our setup, we use VLANs, so I created the make VLAN network adapters. And I was using a script. So during a boot, the script is going ahead and it's creating the devices. So if you go and if you write IP link, you will see the devices which are created. So here we have the ETH1, which is created on top of the ETH2, which is the VLAN device. And then you can see that I'm moving the device which was previously known as ETH1 to ETH0. Magma expects to have two devices defined, ETH0 and ETH1. ETH0 will be used to connect to the SGI interface, which means internet in plain words. And ETH1 will be used to connect to the S1 or N1 interface, which means actually to the G node B or to the E node B itself. OK, we have the interfaces ready, so we know that they are there. And for you, you can see how I've created this in this rename shell script, how the interfaces were created. And then I have enabled them. And then I have went and configured the IP addresses. So let's see how they're configured. So as you see, I have given static address to the ETH1 based on my network setup here. And I have put ETH0 to get the DHCP. And the DHCP are pre-configured. So based on the MAC addresses, we are deploying, we are giving certain addresses to the devices. So I did this deliberately to show you that you can do both ways. So either you can create it with DHCP and log the address on the router, or you can go ahead and create it statically, which means that now you need to put 6 in front. If you are 15, you will be 65 here, yeah, and you will see it in the network. OK. OK, now, once we have done this, we need to go and install Ansible and Python pip and Ansible, which I already did on your devices in order just to speed up the things. And then I'm installing T-Shark and Terminal Multiplexer, because these are the tools which I'm comfortable with. You are not required to install them, but I strongly recommend learning both these both tools are time savers sometimes. And to speed up the things during installation itself, you need to pre-install Ansible with the specific version, 5.0.1. It's not a mistake if you don't do it. The installation script will upgrade or downgrade your Ansible, but this takes time. So, and this is where it can take something even up to 30 minutes. Okay, so then I've created your user, which was called Magma. So let's now create Magma 2 user for me. Magma 2. I will put the password Magma 2. And then when this is done, I have the user, but you don't need to create the user. I mean, it's just to demonstrate how it's done. I will go and modify the user to be part of the sudoers, which means that he can become super user. And then I'm going to go ahead and allow this specific user to become super user without password. This is important if you're installing bare metal. Now we are installing Docker version of HGW. But if you're installing bare metal, some of the tools are depending on your user Magma or your main user to be the super user without password. So here is just to show. Otherwise, it's not important. But in a bare metal installation, it is important. So we already have verified the interfaces. We have verified the IP address. And then I'm going to go ahead, show this IP, show address, show ETH0. OK, I will go ahead. And now, from here onwards, I will also telnet. Yes, I just need to telnet to it and then let's say SSH to it and then. Yep.
I just had a quick question. Do you have any results
We were okay. Let me start the installation, and then we will talk about this. Yeah. So, because it's only one step now. Actually, 2 steps. I will download the script and then just start it, and then we have lots of time. Actually, no. Let me go ahead and answer because yeah, I was wrong. We have a little bit more steps. So. The performance difference, we have not noticed huge performance difference on the data plane. However, some of the scripts, which are some of the components of Magma, due to their synchronization, they're using more CPU resources. Now, why we have not noticed big difference on the data plane? Because actually we are using privileged containers. So basically we are using the host network itself. So it's just different process group. It's not changing much, so it doesn't have internal network. When we were testing this with on a version 1.6, we were testing container-less version which had Open vSwitch inside the container as well. Then we were creating network. Then we have noticed that as long as you create networks which are part of the MAC VLAN or IP VLAN, you don't have performance degradation. But once you go to this VTAP type of networks, then yes, you start using the CPU for the, and then depends on how powerful is your device, you can notice or you will not notice degradation. Okay, so let's go ahead and now we will create the certificate. So I will go ahead and create the folder where the certificate should reside. And I will go ahead and grab the certificate which previously we have created. And now, if you guys did not create your orchestrator, I will give you the certificate later. You just create the file, put whatever you want in this file. Later, we will switch it. We will populate with the certificate. So, which means that you can install HGW before installing the orchestrator. But then you have 2 extra steps to connect to the orchestrator, which means that you will need to populate this file, and you will need to recreate the containers which are going to be created. OK. So I have the file created. Then once again, I need to cheat in the hosts because we don't have DNS for the instance which we created. So I'll go ahead and grab the IP address of the instance which I have created. I'll put it here, and I'll create 3 names. First name is used for the AGW to connect to the controller itself. The other one, the other domain it's used, or the other host is used to bootstrap. So in the beginning, on the first startup, the Magma daemon will exchange the keys with the orchestrator, so it will do the bootstrap in order to make sure that they operate on a secure keys. So this is required only for the first installation, or when the certificates are changed. And then we create the FluentD, which is the host used for the telemetry. Okay, once I give this, I need to create the configuration. I will create once again /var opt magma config folder. And I'm going to create the configuration to tell Magma where to find the bootstrap and where to find the cloud address. Okay, now we have this done. Next thing is to fetch the installation script. It's already fetched. And then I go ahead and start. Now, if you guys give me your email addresses, I can email the kit to you and the configuration file to put it on your device. Mm-hmm.
I was in the process, it's taking a long time to build the orchestrator. I have orchestrator.
Okay, if you have orchestra.
Well, I was at the part where the composers brought it up, but I didn't catch it after that. So.
Okay, we will then go ahead together. Yeah, let me just see this one complaint. Yeah, he didn't like my certificate.
His console cables, can you get them on the VLAN as well?
Yeah, it seems I didn't. Oh yeah, I did it I did it in the wrong window. Okay. Good. Okay, so go ahead and create this one. Create the hosts, do the configuration. And get the and start installing AGW. Let me now check where are you, because this will take some time.
Do you have that markdown file?
Yeah, I have. I can. This is why I'm saying. Send me the email address. I can share the file.
So it's just hard to see.
Yeah, I know. Okay, thanks. Yeah, thank you. Okay, and then Okay, and the email should be on its way. So yeah, meanwhile, we start installing. So we already passed through the installation of the tools, and now the Ansible script will kickstart and working, and this takes around 10 minutes. So to entertain you during this time, I'm planning to speak a little bit about the deployment options which we have in Magma. So as I mentioned several times up to now, you can deploy Magma into multiple scenarios. You can deploy it as a distributed core, which means that on each site where you have the G node B or E node B, you are going to have one AGW. And then you don't need to backhaul all your traffic to the data center. You just need to have the connection to the orchestrator, which means that on the first point of presence of internet, you can go ahead and offload. You no longer need to build your backhaul. So this is the most economical way of deployment in case you have points of presence of internet which are close to the sites itself. Or you can go ahead and use what we call cluster scenario, in which case you go and you deploy multiple sites on one AGW. So you use one edge device to control multiple sites or multiple G node Bs or E node Bs. And basically, you would place this site now, because you're controlling where you're placing this site down the route to your data center, you will place it exactly where your point of presence is of the internet. And then you're offloading all your traffic to that point of presence, and you just use the internet to your data center to have the connection to the orchestrator. The difference between the previous scenario and this scenario is you still need to build some mid-haul, which means that you need to have some transport from this site to the site where you do the aggregation. And then from that onwards, you can offload everything, all the traffic to the internet, and you no longer need to build the remaining backhaul. And of course, you can deploy it in the traditional way that the cores are deployed. You deploy everything in your data center, and then you build all your mid-haul and backhaul until your data center. Now, in LTE, this was not a big problem, but when you come to 5G, because the amount of traffic which needs to be aggregated and the amount of users are going to create these links to be quite expensive. So you need much, much higher capacity. So this is why when we talk to the customers, we usually recommend this option. This is the best option, basically, for the deployment. And it doesn't mean that the cluster could be even only one site. So you have some very remote site, but it has its own point of presence of internet over there. You can use that site as a cluster. Now, in these deployments, you are going to have, you might have as operator certain services which are provided by your data center itself. One example would be the voice IMS. Now, if you have such services, you need to send this traffic to the data center, and you have two options. The first option is to tunnel over internet. Since this is a Linux box and it has software-defined network, you can do multiple ways of tunneling. You can tunnel from the Open vSwitch directly, or you can tunnel as a VPN on the device itself. However, doing this, you are on the mercy of internet itself. So you cannot guarantee the throughputs. You cannot guarantee the quality of service to the subscribers for this traffic. The other alternative would be to still build some backhaul to your data center, but in this case, it will be with much, much lower capacity because you're sending only this traffic. And usually when you talk to real operators, it's something like 80 or 90% of their traffic is internet. So 80 or 90% of the traffic is already offloaded. The remaining 10 to 20% is sent to the backhaul, to the data center. And once again, you can do this just because you have here a software-defined network. You are not limited to one backhaul. So basically, you can have distributed data centers and make decision which type of traffic or which type of services to send to which data center itself. So having said this, we are still installing, and I was too fast in speaking. Any questions up to now? If you deploy it, if you go with this single or everything in your data center, you have two problems here. You need high capacity on the HW because you need to serve the whole traffic. Whole traffic comes aggregated and you need to serve it. And then you need to build this aggregated routes. So imagine if you just very simple mathematics. If you like to guarantee 1 Gbps on each site, you already, when you come here, you need this link to be 2 Gbps. Now, when you come here, it needs to be 4. So as the number of sites is growing and you want to guarantee certain throughputs, your aggregation link will become much, much, much higher.
For scenario one,
It's quite okay as a deployment, but usually if we speak about rural areas, you don't really have the point of presence here. So you have the site, but there is no internet close to the site. So you still need to send the traffic to because you're searching for the first point of presence of internet. And usually it's not there. I mean, if it is there, it's good. If you're doing this into an urban area, for sure you will have point of presence. Or you're doing this in a warehouse, for sure you can assure point of presence, because then you're chasing this LTE or 5G for a different reason. Then you can do it. But in a wireless internet service provider, which is the scenario usually we speak about, this is more of a theoretical. You will not, very rarely you will find a site which is like this. And as I said, if you find a site which is like this site can be your cluster. I mean, nothing prevents you in the cluster way of deploying to have one cluster in a site, and one site in a cluster. And yep, so what I can see here, we already built and then we will see how successfully we have built the kernel module, and then we are waiting for the containers to be downloaded. Now I don't know how fast it will be, and then to start. So Eric, you can tell us a little bit about the CPs which we have here while waiting. And I can check with the guys to see if. Mm-hmm.
So it's still running the.
So one of the beauties of the
Still building it.
LTE and 5G architecture is that it's standard-based.
Yeah, it will. When the orchestrator.
For equipment that you can use. So, one of the, again, going kind of mirroring that, the drawbacks to the proprietary is you're in bed with that particular vendor, that's what you've got, right? So it doesn't drive the prices down. There's just a lot of negatives there. So again, the beauty with this system, any device that is 3GPP compliant will work with these systems, okay? Here today we have devices from BEC. There's the indoor unit that you see over here in the corner. That's the one that's actually connected and active. And then they also have their outdoor unit, which would be mounted on the outside of the house. We tend to push the outdoor devices more than the indoor, primarily because you control your RF environment, right? So the indoor devices, while they work great, only work great when they're where they belong and they didn't get carried down in the basement because, you're sneaking internet and you don't want your mom to catch you, or, things like that, or newspapers get piled on it, whatever. As you start obstructing it, it becomes a problem. And when you're the internet service provider, it doesn't matter why that's not working. If it got moved or if it got covered, it's still your fault because you're providing the internet, right? So we typically push the outdoor units because it's a controlled environment. Where those come in great, and particularly in our climate, we're in Pennsylvania. If, let's say there's an instance where a customer wants internet, there's 3 foot of snow on the ground, you can't get there to install, you send them home with that. They put it in the side of the house facing the tower, they have internet till you get out there and get a, permanent install. So it's just kind of a nice tool to have. There's a lot of uses for them, but, okay. These two in particular are 5G and 4G capable CPE. I don't know what else you want to know about them, Jordan. Any questions?
Slower than I was expecting, so. See, it's still saying, yeah, I don't need that one, I'm wired. I'm not wireless, I'm wired. So, yeah, it's still loading. So, I mean, any questions or people want to know something more while we are waiting? Yep.
5G CBRS. Talk about that. There are 4 sensors.
Mm-hmm.
That's like 40
3.
megahertz. What if somebody wants to run 100 megahertz 5G? You guys counter the situation where that would be kind of combination of both PAL and
Right, right. So the question is talking about channel sizes with CBRS and 5G. So clearly one of the big advantages to 5G is the ability to do larger channel sizes and not be as dependent on carrier aggregation, right? Carrier aggregation is a wonderful thing, but there's overhead involved. So, yeah, so any PAL owner can only own 40 megahertz, right? So while 5G is capable of a channel up to 100 megahertz, you can't necessarily create a 100 megahertz channel out of PAL and GAA. What you can do is have a 40 megahertz PAL channel, a 40 megahertz GAA channel, a 40 megahertz GAA channel, and carrier aggregate them to get the higher speeds.
So that would you would get 2 or 3 grants, separate grants.
So yeah, so the way the grants work, every grant is a 10 megahertz channel, okay? The RAN device then combines those into a carrier. So for me to do an LTE, a 20 megahertz carrier, that's technically 2 grants still. Or I'm granted 1 grant, but I'm granted for 2 10 megahertz channels. In the event that a SAS event happens, a DPA event, whatever, if it affects one of those 10 megahertz channels, I'm able to continue to broadcast on the other 10 while another is found. And the way this works, one of the advantages of a carrier grade piece of equipment is this has an IBW of 150 megahertz. So I can combine, or I can carrier aggregate anywhere in the entire CBRS field, right? The other thing that happens is when the way this particular equipment works, when I request a grant, my domain proxy is going to go out and it says, okay, I want a grant for 150 megahertz. Give me the whole thing. Once it gets whatever it can get out of there, it then pairs down to what you actually want. Because the radio maybe only wants 40 megahertz. It's going to ask for the entire 50. When it gets that entire 50, it's going to look at all those 10 megahertz blocks, and it's going to say, you know what, these 2 are contiguous. I can create 1 20 megahertz channel out of this. These 2 down here are as well, or maybe I've only got 2 10. So it kind of finds what is contiguous first, because that's most important. The second is what's available power-wise, if I get full power and how clean the channels are. So it makes a lot of those decisions for you. And then, of course, in the event of a DPA event, something to that effect, it's going to go out and do that same thing. So it's going to get the notice to stop broadcasting. It's going to go out and do another grant request, search for what's available, pick it up, and take it from there. Does that answer the question? Or? Yep.
So on the, what we can see, it sounds a lot with 100 megahertz, but what we can see, most of our clients are actually using 40 megahertz in 3 sectors. And if you have availability of spectrum, what you typically would do, you would avoid using the same frequencies in all 3 sectors. So in essence, most of our clients are able to find 120 megahertz per site. Meaning with 5G, we could actually get the 100 megahertz channels and do the speeds we're talking about. And what we'll hopefully see when this download is finished, when we have been doing the testing on 40 megahertz, we've gotten 550 megabit down just on 40 megahertz, and on the uplink 55 megabit. So with 40 megahertz, 550 down, and about 55 up. We're waiting and eagerly waiting for the CPEs in the CBRS band that are able to aggregate like 100 megahertz. And we are hopeful we will reach more than 100 megabit in the uplink. For sure, we'll reach the 1 gig down. But the uplink is the big challenge for most CBRS clients as of now. You're smiling, so you know that. Yeah.
How you provision the SIM card to the customer?
So the SIM card in LTE is going to be provisioned in the HSS, right? So there's a couple of options. There's UE Amber, of course, and then there's the APN Amber, right? So you have options of how you do it. We typically do everything with APN Amber. We set and say, APN Amber. So we'll go in and we'll set what our maximum minimum is. When the device connects, it connects to the MME first, does all its magic there, reaches out to the HSS and says, what am I allowed to do, right? And so that's when it knows at that point that it can do those speeds. So that's all done. Again, the HSS is typically a GUI type application, or you can do it through APIs. A lot of our customers will have an API call written for their billing system. So when they're entering the customer into their billing system, it goes out and does all the configuration for them. So all of that's done in the EPC.
Or you can do it manually. I mean, we just created one SIM card manually when I created a subscriber here. So basically, this is what I was doing. But the keys were pre-prepared before. So yeah, usually your SIM manufacturer is going to.
So just stepping back to just a minute to something Patrick was talking about when we were talking about anxiously awaiting CPE vendors to get caught up with the capabilities of the RAN. So with this particular RAN setup here, I'm capable of 7 carriers on the downlink, 5 carriers on the uplink. There's not a CPE out there that can do that for us right now. And in particular, on the 5G side of things, right now, with everybody we've worked with, we're limited to a 40 megahertz channel on the uplink, no more, no less, no carrier aggregation. And we have 2 40 megahertz channels on the downlink. But in those 2 40 megahertz channels, there's only 60 megahertz of throughput available with that particular CPE. So we're anxiously awaiting the new chipsets and the CPE vendors to get caught up. So the limitation's not in the RAN or the EPC. It's right now it's in the customer equipment.
Yeah. In the last mile of 5G and 4G. I mean, usually always we have the limitations in the last mile. So even here it's in the last mile. Yeah, I mean, and then while we are waiting, how you can get your own MNC MCC?
Google it. So I don't have the site in front of me, but yeah, it's actually a pretty simple process when you want to do that. Now, when you're talking CBRS, there's a CBRS specific block already for that. And I'm drawing a blank here on what the third section of it's called, anyways. But you know, the MNC, the network code, the MCC, the country code, and then I am drawing a blank on the third one. I apologize. But anyways, basically, essentially, you go out, you register for it, you put in your request. Typically, what we've seen is approvals within 30 days or less, and you have your number available to you, and you can start printing your own SIM cards. Now, what we do as part of our service, we already own I won't say own, but a block of the CBRS block, so we provide the SIM cards to all of our customers. We segment everything for their network, so they're all using our IMSIs, but the MNC, MCC, of course, which is part of the CBRS block, but it all comes back to our sub-network code. So they're all using that, and we just segment from there so they can go ahead and broadcast.
Okay, and I think we are just on time. So everything was installed. Now, just before rebooting, I will just move probe, port GTP. This is the kernel module which we are bringing. Yeah, and if we say we cannot insert, this is a good message because it means, yep, that we have not restarted, we have not rebooted. Now, next step for me would be to go ahead and reboot the device. So just let me make sure that I know where I am. Yep, and we go and reboot.
So yes. Now, again, the way we do it when we provision these, we're typically providing the core services too. So we put in the IMSI mask that's allowed to connect in the ranges, so that eliminates that amongst our customers. What we have seen particularly in the early days of the fixed wireless LTE and some of the entry-level products, that they were using one IMSI range for customers everywhere, similar to what we're doing, but they weren't segmenting it. So yes, I could take a CPE or an IMSI from my network in Pennsylvania, and if I was in Texas, I could plug it in my car and hook up to somebody else's because there was no blocking on that. They have since, and I'm not here to pick on any vendors by any means, it was a lesson learned for them and they've solved that. But yes, if you're not particular, one of the things you can do is you can put in a IMSI mask that just says allow anything. And if you do that, and that IMSI is in your HSS and that IMSI is set to active, absolutely.
Yeah,
so
correct.
the way it impacted the other network, it was a cloud core. Everybody connected back to the same core, the same HSS and everything else. So that's how that happened.
I was asking for more of a situation where, let's say this hotel has their own CBRS network, the one across also has a CBRS
Mhm.
network. Both of them broadcast the same PLMN, and then the device doesn't know whether to attach to this one or attach to that one. And like UV's trying to attach.
Right. So again, that's going to be handled in the subscriber service, the HSS, because even if they're both broadcasting the same PLMN, for now we'll just talk about, let's say, the last four of the IMSI, right? If 1, 2, 3, 4 is not listed in Hotel A's HSS, the device won't connect.
Yeah, it won't connect.
That I know, but that's after the fact. After
It will certainly scan that network, yes, and try to connect.
There's a concept of CSG ID, right?
Let's just continue and park the question. Sorry to interrupt both of you, but yeah, let me just finish because otherwise we will run out of time. Okay, so now the device is rebooted. I will use LS mode just to make sure that I see here the vPort GTP loaded, and which means that everything was perfectly with the installation of the kernel modules. And next thing would be to go ahead and try to register this now with the orchestrator. So I'll go in the place where the Docker compose file is stored. I'll go ahead and make sure that all the containers are healthy and up and running. They're up and running and they're healthy. And then I'm going to execute the command, the Docker command, and call Magma D. And Magma D is the orchestrator on the AGW. So we have the orchestrator module on the AGW, which talks to the cloud. And this orchestrator module is going to give us the key, the hardware ID, and the challenge key, so we can establish the secure connection. So once I have the hardware ID and the challenge key, I go back, I go to my orchestrator, I go to the equipment, and it's time for me to add new gateway. And I'm going to call the gateway AGW001 because it's the first one, AGW001. Now I'm going to go and grab this hardware ID, say this is my hardware ID. I'm going to grab this challenge key. I will say here description is the test AGW. I will use the challenge key, save and continue. Then I'm asked how do I want to aggregate the events which are sent to the orchestrator. Yes, I want everything to be aggregated. I don't want to use CPE monitoring. Then we are going to specify what will be the network blocks which are allocated to this AGW, and this is where the mobility can also come into play, where you can allocate different subnets into each AGW and then use a device in front in order to route the traffic. So I'm already, so I will leave everything as it is. Then in certain cases, AGW can control these small radio units. So in this case, we can define the information for the radio unit. In the case of Ericsson, we don't need to define anything. We are continuing. We will skip the APN resources because we want to use everything, and we are not going to use header enrichment. Now, speaking about performance, if you use header enrichment, you need much more processor power because then everything goes to the user space of the. It doesn't stay into the kernel space. It goes to the user space, and there is lots of processing, and then, of course, you are going to experience huge problem on the performance. Okay. I save and I continue, and by definition, the health of this AGW, since we created at the moment, is bad. So then I go back to my AGW, and then I'm going to tell my AGW to restart. So I will go and recreate, which is going to speed up the phone home process. And now, as I said, if we skip the key, so this will be now the time to put the proper key and the proper configuration. And then instead of once, we will need to recreate it twice, because for the first time to read the keys and for the second time to phone home. Okay, so we are waiting for the containers to be restarted and recreated. And after this one, very soon here it needs to say good. So we will give him some time. Yeah, and it's good. So the device is already established the connection, and now we have secure connection, and the device is downloading all the settings from the cloud itself. And in our case, it will be only one subscriber. So to speed up the synchronization, I will go ahead and restart all the containers. There is no need, but it will take up to 5 minutes to synchronize the things. So I go ahead and restart the things. And once this is restarted, I will go ahead and check if we really have the subscriber. So now I'm going to call the subscriber database and see who is registered as a subscriber on this node. And yeah, I see our subscriber, which we created previously in the orchestrator. Okay, so once we have this, now it will be time to start splitting the screens. So we have more screens to look at and to start integrating. Okay. So T-shark minus E, TH1. So we will monitor here with T-shark what is the messages exchanged on the interface toward the run. And then I'm going to go ahead. Okay, I'm going to go ahead. We will leave it like this and connect to my run. So here on my run, I need to, and you can download this. Pre-prepared SRS run, or you can compile it by yourself. And then I have here the environment file, in which environment file I have defined the IP address of the node itself. And now I need to put the IP address of my device. Show ETH1. So my IP address is 252.10.70. 252.10 and is 70. And then the IMZ is the IMZ which we already defined. So once this is done, I go docker compose up minus force recreate, because we have the previous configuration. Okay, and then the simulator started. Now if we go back to the AGW, so here we are already seeing the communication on this side. But if we go to the AGW, we're seeing the communication on this side. So we have sent the setup request from the simulator, and then we responded with the setup was accepted. So we already integrated the site there. If you see this, it means that the site is up and running, so everything is OK. Now we are waiting for the subscriber to connect to the site. And this takes a little bit on the first start of the SRS run, because the SRS run is preparing the channels. So any moment now, he needs to go ahead and connect. And then we will see additional messages. So we will see the attach procedure, as it is known in the 3GPP standards. Meanwhile, I mean, you can notice that we are exchanging the heartbeats. So basically, if everything is healthy, the AGW and the run device, the G node B or E node B are going to exchange from time to time the heartbeat messages in order to make sure, and these heartbeat messages are going into both directions to make sure that they're still operational. And now we start attaching. So you can see the whole procedure going for the attach. I mean, we will not go into the details of this. You can record this message with T-Shark and go and analyze. Usually, when we start integration in real conditions, the first attach is not so smooth. I mean, it's smooth because we tested this 20 times. Even yesterday, we tested 3 times, just to make sure it's smooth like this. But usually, the first time is not smooth. So something is wrong in the configurations. And today, it was mentioned on the keynote that in 5G, we have around 4,500 parameters which we need to configure. So definitely, something will go wrong. So then we record these messages, and we see what's wrongly configured, and we go and change the orchestration and restart the containers again. And usually, it's configuration of the APN or configuration of the SIM card itself, wrong keys, and so on. So once we have this, we have now allocated IP address on our device, simulated device. So we go ahead, and we will ask AGW which are the subscribers which are currently connected to this node. So we see our subscriber is successfully connected, and it already has the IP address. So which means we go ahead, and then we can use ping. I will use the interface which is created from the device, and then hopefully we will have ping, and we have ping. So basically, we have live traffic from the simulated user equipment, from the simulated device, through the simulated E node B in this case. We are passing the traffic through the AGW, through the core. And here, as you can see, we have the GTP packets. And everybody knows 1.1.1.1, the standard site where you make sure that you are connected to internet. You can do 8.8.8.8 as well. I mean, ping the DNS. So with this, our setup of the LTE network is finished. So now we have LTE network. If we had a real E node B, now we would be able to attach our devices and use it. OK, so having said this, I promised that I will show you how to configure the 5G. So this one, it's quite easy. So now when we have everything configured, we...
To be clear, this is the same device now that you...
No, we will use at the end, we will use the 5G over there because of some changes on the configurations and the modules. But here, when you need to connect the 5G, you are going to the network, edit JSON. And here inside the EPC, you are going to insert the key, which is called enable 5G. And you will say true. Do this, restart your AGW. Congratulations, from 4G you became 5G operator. So that's it, as simple as that. Now, having said this, I'm not going to do it in this network. But let's go and connect to the real site. So I'm already connected here. So you see, here we have the CP, which is connected to this antenna, which was all the time behind me. And Eric assured me that the power is very low. So I don't have problems. So we have the connection. So we have the heartbeat, as I was saying all the time, the heartbeat was going. And then we have the ping. So from the AGW, we are pinging the device, and the device is responding. And from here, you can see the latencies which we are achieving. So they are not always the same latency, and this depends on the radio conditions and on the setting on the frames itself. Now, where is Eric? No, Eric needs to show the device. This is the CP, yes. This one is connected here. Yeah, this is the one which is connected to the radio over there. I mean, if somebody wants, you can just plug cable here and you will get internet through the radio over there. But Eric had the ability to connect his phone to the CP and show the speed. So if we find him there, so there it goes. Any questions now? Yeah. The Magma orchestrator and the HW, you mean? Which one? The DigitalOcean. No, we installed the orchestrator in the DigitalOcean. This is a cloud site. So I've created a cloud node over there, and I've installed orchestrator over there. You can install on your laptop, you can install on Amazon, you can install anywhere. So there is no connection between the DigitalOcean and the orchestrator. Now, the orchestrator itself has the connection with the HW, with the device, in order to provision. Because if you remember, we created a subscriber in the GUI, and the GUI is in the orchestrator, so the GUI is in the cloud. So we created the subscriber, we created the SIM card, and then when I restarted this device, it was already provisioned on it. So what happened is that this keys which we used, this device phoned home to the orchestrator. It established the connection. It exchanged the secure keys. Once the secure keys were exchanged, it fetched the subscriber database. So basically now there is a copy of the subscriber database in this device. I can switch off the orchestrator. Everything will continue to work. So I no longer need the orchestrator for this device until I provision new subscriber or I change the settings. So this is the connection between the orchestrator and the HW. So Eric, if you can show us now the speed test from this device, and yeah.
So I'm going ahead and running a test from my phone to the Wi-Fi. Understand that our backhaul is limited to what we're provided here, but the important piece is to show you what we're going to see on the uplink.
And I need to move away from the beam.
Give me 1 minute, it's running now. And this again is a single 40 megahertz channel. And in this particular case, we are at about 45 on the downlink, 45 on the uplink. So typically, and let me just get another one started while we're going here.
Yeah.
So in the LTE world, right, when you're talking about a frame config, or subframe, subframe config of 2, on the uplink, you're typically limited to about 12 megabits on the uplink for a 20 megahertz channel. Carrier aggregation, you're going to get up to around 20, 21. In this case, again, we're taking away the overhead by using a single channel, and we're able to, what we would do in 40 megahertz and, like I said, get around 24 on a subframe config 2. And on a subframe config 1, you'd be limited to a rate around 40. Here, we're getting up in the neighborhood of 50 to 55 every time.
Yeah, and I've started the...
Oh, you've got it down there as well. There you
no,
go.
actually, I'm showing the CPU now. So you see there is not much on the user space.
So by going to the larger channel size, taking away the overhead of carrier aggregation, you're able to get better performance that way. So.
And we are finished. I mean, questions?
You're showing 5G right now?
Yes. Right now, this is the 5G. I mean, this is the switch is just literally one switch, so we cannot create it more complex than that. So, and the reason why we didn't use this device, we used that device over there, is just because on that device we have the latest version for the CP to attach, because this CP will not attach on the 1.8 version itself. So this is the only reason we are using that one. Please go ahead. Eric? Yes. Govin.
I'm sorry, say that one more time. Yes, it is called, stand by 1 minute, WLAN something. Yes. And it should not prompt you for a password. You should be able to get that.
Yeah. Feel free. So yes, I mean,
We're limited downlink
yeah,
by what they're providing to the room.
correct.
It gives us plenty to show the uplink.
Yeah, and on top of this, we have router which has only 100 megabits. Yeah, to the backhaul. So yeah. So basically, yeah. So basically, in this scenario, what we did is we used the CP to provide Wi-Fi, but the backhaul of the CP is 5G, and the backhaul of the 5G is this device here through the hotel. So we have two backhauls. Yeah, by the hotel throughput. Yeah, I mean, the radio, as Eric said, the radio itself, we are limited either to the CP or we are limited to the, to the backhaul. The radio and the AGW, we cannot reach the limits.
If we had a full
There
pipe
will be
here,
limits, by the way, but we cannot reach them because of these two bottlenecks
right.
over there.
Yeah, if we had a full pipe here on the downlink, you'd be seeing closer to 500. So.
Correct.
So people who have 5G phones, can they connect directly to the network?
No, they need the SIM card to be, so no. The MCC, MNC, which is radiated, you will not be able. But some devices you can search. So if you search on some devices, you will be able to see. Depends. Some Android phones will allow you to see it, but not every.
And it's 5G standalone, right?
Yeah, it's 5G standalone. Yeah, yeah. Yes, we need to give you SIM card, which is with this MCC, MNC, then you will be able to connect. Yeah. And I don't remember if I took one. We can get one from the CP basically and try.
I think my phone does not do 5G anyway.
Oh, okay.
And that's going to be a large.
Yeah, because you will need the SIM card. You will need the SIM card. The SIM card contains information which network you are allowed to connect to, and this network will not be there. Yeah. Neither 00101 nor the network which we use for the Xtreme LTE.
You have 5G?
31318. Yeah, this is the one which 315 should be.
315.
315. Yeah.
So
Correct,
this is
315.
a 5G phone and you're directly searching.
Yeah.
Yeah,
for
it's
it.
5G. Yeah.
So 315 should be. No, this one. It's
This one. I'm
no,
trying to connect.
no, no. It's not. It's not this one. It's not. It should be 315010. 315010. This should be the network which we are radiating.
So when we were on the site, you saw on the picture in the beginning of this, on the same setup where we're not limited by the hotel LAN, right? We were pulling 550 down and 55 up. And now on the Wi-Fi, I just did the speed test here. What I got was the 85 down and about 45 up, but it's more the internal network here.
So if you find
Equipment.
That's the thing.
Yeah. So yeah, let's speak.
Then you will see.
We can speak about the equipment we have here, right? So you see this antenna here?
iPhone you will not.
If you want to come up and have a look, we're a few people here.
Unless you have the SIM card, you will not.
Yeah.
No, because it
But if you want to
only on
come,
Android,
this is
yeah,
actually
because
the Ericsson High Runner that
No,
is being
you-
used
you
here.
don't
That
may
we,
know which one
the
is
radio is called 4408,
Okay,
so it's a
then-
4x4
but you will not find
MIMO.
it. iPhone will
It's
not
a
show
bit
it to you.
informally
Security. Yeah,
installed
because-
here, right?
Because it's not.
But what
in
you
the-
can see here
because
is
not
that
in the
it's
list of
four-
the, in the SIM card there is a list.
4 outputs.
So in the, in your
So,
SIM card,
and
in
then
the
it's
list,
connected
this
to the
network is not
antenna,
there.
and these
So it's
are
not showing
the
you.
antennas that are
But if
typically
you put
used.
this SIM card,
It's a
that network is in
4x4 cross-polarized antenna. Here's the GPS. So this is the live testing, and then it's connected then to the indoor CPE that's on the table here. So, and then as a core network, it uses then the one that you have been working with all afternoon. And this is what's called the baseband. It's a baseband 6630. So that is, so this setup is one of the high runners for CBRS that we use for LTE. And then just by upgrading it with software, we can upgrade it with to 5G. And we did that literally when we were testing it. We do that in about 1 hour. We can do that conversion. And you now saw how easy it is to convert from LTE to 5G also on the Magma, right? So yeah.
One of the beauties of the split architecture with the RAN here is, so one of the beauties of the split architecture on the RAN is all of the brains are in the baseband, okay? So I can simultaneously broadcast CBRS, I can broadcast band 41, any of the spectrums, the licensed spectrums that are supported, I can broadcast from the same baseband. All you're doing is changing the radio head, and I could do that simultaneously. So the idea being with the split architecture is when it's time for an upgrade, let's say we need to do an uplift to the site, you're replacing what's down bottom or you're doing software. There's no tower climbs involved. These are just a dumb transmitter. In this case, when we start talking about massive MIMO, that's a little bit different story. There's more to it than that, but.
So I believe this is doing four layers, right? For this standard throughput that you're talking about. Yes. In 40 megahertz, if you're doing 500 megabits per second, it must be 4 layers.
Yeah. So it's a 4x4. We haven't yet set it up with a 64x64, but on the LTE version we have tested it with 64x64.
In a field environment, rural outdoor, you're not going to see the 550 necessarily, right? Because you're not going to get all 4 of those layers. This is all lab, so we're getting near perfect conditions, certainly, but you're still going to be, well within what you're looking for. So. I'm sorry, what's that?
Magma just runs on this.
So Magma is the core piece. That's what runs on the small, the solid run box that we're talking about. This is just the radio network that then attaches through that.
When you say 64 times 64, you have 64 here and 64 over there. So this is the 4x4 on top. Yeah,
right.
But when you speak about 64, it cannot be 64. It's from 64 and 4.
You mean
Correct.
on the upstream?
So,
Yeah, on the upstream.
right.
Yes. But downlink 64 by 64.
And what that gives you is the ability for the beamforming, building layers, and all that, right?
MIMO,
Yes, yeah. But you're right. The CPEs will not.
64 layers.
Correct.
Correct. 4 layers. You are able to push through, because you have diversity channels.
Right.
You can serve many in the same sector, in the same cluster.
And then by creating with the multi-user MIMO, by creating those layers, now you've added more resource blocks to increase your capacity.
So should we formally end the session? So they.
In any case.
Yeah. Thank you. So Jordan, should we formally end the session? And end yet.
Oh.
We will, for those of you that did follow, we'll actually, as a gift, you will get.
But you have my email address.
You
I
will
can
get the
give you
AGW with you.
I'll give
Yeah?
email support.
No, those of you that were working on it, you're going to get.
You get your device.
You get your device. Yes.
So
Yes.
you get your device.
Yeah.
Congratulations.
But only if you succeed.
You suffered now. Let me give you my.
I will give you my contact details. So again, I'd like to say a thank you to the Linux Foundation for arranging this workshop. I'd like to say thank you for Arm and the partnership we've had with Arm throughout this process. And also I'd like to say thank you to our partner Xtreme LTE, and now they just renamed to Xtreme5G. And then as we mentioned in the beginning, Connect 5G, what we do for a living is really telecom services and helping end-to-end integration, including the radio integrations as well as the core network piece of things in Magma. So, and our chief architect, Jordan. So thank you so much, Jordan.